Hello, my name is Tania Neri from the National Polytechnic Institute, and I will present a statistical analysis of zinc oxide characterized by X-ray diffraction. This work evaluates the reliability of an X-ray diffraction measurement system used for zinc oxide characterization from a cross-gauge reproducibility and repeatability study. All measurements, by whatever their principle, are subject to inherent uncertainty. This is true for analytical equipment such as the X-ray diffractometer, where the condition of the instrument, user influence, and the sample itself contribute to the variability. Added to this, the processing and refinement of results using different softwares also introduce a degree of variance. In the X-ray diffraction technique, seeing parameter variation can lead to misinterpretation. Specifically, variation in the angular position affect lattice parameter calculation, while changes in the full width and half maximum impact the estimation of macro and micro strains, as well as crystalline size. These parameters are critical as they determine the structural characteristics of the sample and directly influence its physical properties. Methodology. The study involved the measurements of four samples corresponding to two powered sites oxide samples obtained from simE6-abs055 synthesis via the soft-gel method. To induce microstructural changes and obtain geometrical necessary dislocation within the samples, thereby promoting full width and half maximum narrowing and observing the K-alpha-1 and K-alpha-2 splitting, the samples were annealed in the muffle at 915 degrees Celsius. The first sample underwent an intermittent treatment, while the second was treated continuously. These were analyzed by three users, an advanced user, and two trained engineers, with four replicates each. Measurements were performed using a pananalytical expert probe diffractometer equipped with a pixel detector and copper rotation operating in the range of 30 degrees to 70 degrees. The evaluation focused solely on the primary parameters, angular position and foot width and half maximum, using Rigaku software from a wool pattern fitting deconvolution by the split pseudovoid method. The reproducibility and repeatability study was carried out through Minitab. The diffractogram confirms the presence of a poor zinc oxide phase. Upon subjecting the samples to thermal treatment, the splitting of the 1 and 2 doublet is observed. This indicates an improvement in the crystal structure quality, with another sample 2 exhibiting the crystalline size of 440 angstroms. This is consistent with the same analysis, figure 2, where sample 1 exhibits an asymmetrical morphology with spherical tendons and surface agglomerates. In contrast, sample 2 presents a smaller particle size and a cylindrical geometry with a smooth surface. After thermal treatment, porosity completely disappears, resulting in a clean and homogeneous surface. In the figure 3 shows no statistically significant variation regarding the angular position, confirming high reproducibility between users. Furthermore, figure 4 illustrates how peak broadening full width and half maximum, and its dispersion increase with angular position with annealed sample 1. displaying better behavior due to this linear trend. Nevertheless, size, both unneeded samples 1 and 2 showed great dispersion. Careful sample manipulation is required to minimize this variability. Finally, figures 5 and 6 illustrate user variability. User 1 and 3 maintain a statistically identical dispersion, whereas the user 2 shows less dispersion and a smaller experimental error, despite the presence of outliers and slightly different behavioral patterns. The gauge R&R analysis indicates that, regarding reproducibility, not head treatment samples exhibit a variation that depends primarily on the inherent nature of the sample, rather than on preparation and measurement. Conversely, heat-treated samples are more sensitive to preparation. In this case, sample mounting must be performed by trained personnel to minimize full width and half maximum variance.